welcome you all in this session. As you are aware, in previous session we were discussing about chi-square goodness of fit test, wherein we have seen how observed data and expected data are similar to each other. So, in chi-square goodness of fit test, we see the expected frequencies and our actual frequencies, whether they are similar or not. If they are not similar, then we sometimes reject the null hypothesis. Generally, the hypothesis in goodness of fit is that they are similar to each other, right. So, if they are not, then we reject the null hypothesis, otherwise we do not reject the null hypothesis. We have also seen chi-square goodness of fit as a replacement of Z test for hypothesis testing of proportion of one sample. And in fact, we did see how to apply chi-square goodness of fit test for comparing proportions of two groups or two populations. In previous class, we did discuss hypothesis testing of proportions of three groups, and we did solve this particular question using chi-square goodness of fit test. So, we will see once again. I will quickly go through this question. So, the null hypothesis here is that the proportions are same, right. So, pi 1, pi 2 and pi 3 are same, right, and one of them is different from others, right, is alternative hypothesis. So, we need to calculate this overall proportion first of all, which is 0.733. So, all these are observed frequencies, right, and the expected frequencies would be 0.733 multiplied by 216 for those customers who would come again to this particular hotel, and 0.267. How did we get this? This 1 minus 0.733, right, is 0.267 multiplied by 216. So, 57.7770 customers said they will not come to that particular hotel, right. So, this was our null and alternative hypothesis, and when we calculated its chi-square value, it came out to be 40.23, and the critical table value was 5.99. So, we rejected null hypothesis. So, this was our rejection region, critical value 5.991, right, 991, and this was our calculated value 40.23, right. So, we will reject the null hypothesis and we will say that these three proportions are different, right. So, let us solve this question using Minitab. So, first of all we will go for data entry. So, choice of hotel. So, you have got Golden Palm, Palm Royal and Palm Princess. Now, the choice of hotel, yes or no. So, these are observed frequencies. There is no need to write total value for these two rows, and there is no need to write even total of column values, right. So, just go to state, tables, chi-square test of association. In fact, you can apply this. So, select all these three statistics. So, we have got the we are interested in chi-square statistics, which we have clicked OK and OK, right. So, just look at this, these are in fact expected values, right, is not it? And how did we calculate these expected value in our question? It was just row total, it means 513 into 216 divided by 700, right. It was row total into column total divided by total number of observations, right. So, let us look at chi-square value. First look at p value, p is 0, right. So, p is less than alpha. So, we will reject the null hypothesis, and the null hypothesis was that all these three proportions are same. So, we are saying they are not same because we have rejected null hypothesis. So, far as chi-square value calculated is concerned, it comes out to be 40.96. Just check whether we were getting the same answer or yeah, 40.23. So, approximately one and the same thing. In fact, yeah, this is exactly same, right. So, this is Pearson chi-square is 40.228, just see this, right. This is what we have calculated over here, 40.23. Okay. So, we will reject the null hypothesis. Now, let us look at some more applications of chi-square test. So, we have seen chi-square goodness of fit test. Now, let us look at chi-square test of independence. Generally, chi-square goodness of fit test is used to analyze distribution of frequencies for categories of one variable. So, the examples which we have seen so far, they were having only just one variable. For example, the number of customers arriving at a bank counter, determine the distribution of whether the frequencies are same as hypothesized or as expected. So, the goodness of fit test cannot be applied when you need to analyze two variables simultaneously, right. So, for that you need another technique, it is called chi-square test of independence. So, this can be used to apply to analyze frequencies of two variables with multiple categories to determine whether two variables are independent or not. So, let us look at what could be the examples of chi-square test of independence. So, let us say we want to know whether the soft drink whether the type of soft drink preferred by consumers is independent of consumers' age. So, are they dependent or they are independent, right. So, we always say they are independent, right. For example, an organizational behaviorist might want to know whether absenteeism is independent of job classification, or whether the type of preferred stock investment is independent of region where the investors reside. So, it is the test of independence. So, we will say whether age is independence of coffee consumption, whether studies is independent of good score, whether more studies independent of good score, and so on, right. So, you can have several types of hypothesis test wherein the two variables are independent of one another. So, this is very similar to chi-square goodness of fit test, and this is similar to what we have seen earlier, wherein we did compare proportions of more than two groups, right. So, the same concept is being extended over here. So, null hypothesis is two categorical variables are independent, right. So, there is no relationship between them, and alternative is there is a relationship between them, right. So, how to calculate chi-square statistics? Same formula here. So, FO minus FE whole square divided by FE. So, FO observed frequencies FE expected frequencies, chi-square statistics, value, the critical values to be seen at r in r minus 1 and c minus 1 degrees of freedom, right. So, here r is number of rows, c is number of columns. Decision rule remains same, there is no change in it. If chi-square statistics is more than critical value, then we will reject the null hypothesis, otherwise not, okay, and at this particular degrees of freedom, right. So, let us look at this question. The meal plan selected by 200 students in an institute is shown in this table. So, these are total 200 students, right. So, the class standing can be in first year, second year, third year and final year, right, or fourth year. The number of meals per week, the options available are 20 meals per week, 10 meals per week and none per week. So, we will say that there are 24 first year students who have taken 20 meals per week, 14 did not take even a single meal per week in a mass, let us say, for simplicity. Similarly, 14 students of fourth year have taken 20 meals per week and 10 of them did not take even a single meal per week. So, the null hypothesis is class in standing independent of number of meals per week, or in other words, is there any relationship between the number of meals taken by students and their class standing. So, this is to be checked, right. So, we will say that null hypothesis meal plan and class standing are independent, right, and their dependent is alternative hypothesis, right. So, meal plan and class standing are independent, or there is no relationship between them is alternate is null hypothesis. So, first of all, you need to calculate expected value for each of these cells. These are different cells wherein we have written observed frequencies, right. So, FE are expected frequencies row total divided by column total. So, 70 into 70, right, divided by 200, you will get 24.5, right. Let us say if you want expected frequency for this particular cell, so 70 into 42 divided by 200, you will get this. Similarly, for this, what would be the expected frequency? Row total, which is 30, into column total, which is 70, right, multiply both of them and divided by 200, right. So, this 10.5. So, this is how you can calculate expected frequencies. When you solve this question by chi-square statistics, this comes out to be 0.709 and at alpha is equal to 0.05 and at 6 degrees of freedom, it is number of rows and C is number of columns, right. Let us see how many rows and columns are there in this question. So, there are 4 rows 1, 2, 3, 4 and columns are 1, 2 and 3, right. So, row minus 1 into column minus 1 will be degrees of freedom. So, the critical value is this and observed value is this. So, in fact, you can check whether this is chi-square statistics is this. So, at 6 degrees of freedom, 6 degrees of freedom, this is the one, and at 95, right, yeah, this one 12.592, right. So, this is 12.592, is not it? This is how you can check table value of chi-square. So, this one is your critical value, it is 12.592 and the calculated statistics is this, which is in non-rejection region, is not it. So, we will not reject null hypothesis. We will not reject null hypothesis, it means what? We will not reject null hypothesis, it means they are independent, right. So, there is no sufficient evidence that the meal plan class extending are related. So, they are not related with each other, they are unrelated with each other. Okay. So, let us look at how to solve this question using Minitab. So, first of all you just delete all this output and we will have data entry once again. So, class extending first, second, third and fourth year, right. You got different meal plans, 20 per week, 10 per week and none per week. So, these values are 24, 32, 14, then you have got 22, 26 and 12, 10, 14, 6, 14, 16 and 10. Let us solve this question. So, table, in fact you can directly go for chi-square test for association, is not it. So, this is what you have obtained. So, the chi-square is this, just 0.709, exactly same what as what we were getting, right, 0.709, is not it. And the expected values can also be seen over here. So, let us say this is expected value for, so for first year the expected value is this, right. Right, it is 24.5. How did we get this? It is row total into column total divided by 200, right. So, we are getting same answer, right. So, this is how you can look at other values, you can just go down, yeah, just look at the p value is 0.990, right, while alpha was 0.05, right. So, p value is less than alpha? No. So, we will not reject the null hypothesis, right. That is what we did in our question, right. So, this is how you can use Minitab to solve questions on chi-square test of independence. Let us look at some more examples. So, the question is like this, a survey was conducted amongst nurses of hospital, and the survey was conducted in 4 different regions of a country, east, west, north and south, and they were asked a question whether they would like to have salary every year, which is the old method, every month, or they would like to have salary twice in a month. So, when the question was asked to, let us say, 100 nurses of east region, 68 favored the old method. It means they wanted salary every month, while 32 said that they wanted twice a month, right. Similarly, for west, north and south, right. Now, we need to test this hypothesis at 0.10 significance level. So, so the question is, are these 4 proportions same, or we can put it like this, the proportion of nurses preferring new method is same across these regions, is not it. So, you need to have null and alternative hypothesis. So, you have contacted total 420 nurses, 279 preferred old method, 141 preferred new method. So, null hypothesis is this: proportion of nurses are, let us say, the job evaluation method is independent of geography, right. So, you can frame your null hypothesis in this way. So, we are saying that is job evaluation method, in fact job evaluation is nothing but how are they performing, right. So, proportion of nurses in east, west, north and south is same, is our null hypothesis, right. So, alternative hypothesis would be is dependent, right, only this much change will be there. So, expected frequencies again row total into column total divided by 420, right. So, or you can have expected frequencies in this manner as well. You just calculate the overall proportion first of all. So, 0.66 multiplied by 100 is this, 0.66 multiplied by 120 is this, 0.66 multiplied by 90 is this, 0.66 multiplied by 110 is this, right. And how to get this one? It is 1 minus 0.663, right, 6643 is equal to 0.34. So, 0.34 multiplied by 100, 120, 90 and 10, right. So, either you calculate expected frequencies using this way or simply row total into column total divided by total number of observations, right. So, I think the method of calculating expected frequencies row total into column total divided by n is simpler, right, compared to this one. Okay. So, let us look at the solution to this question. So, you have got all these FOs over here, all FEs over here, FO minus FEs, some of them are positive, some of them are negative, but the moment you take square of this particular column which is here in this column, all values are positive, divide each of these values by FE, right. So, let us look at this 2.46 divided by 66.43, right. So, you will get 0.04 and so on. So, when you take the sum of this, it is 2.64. So, calculated chi-square statistics is 2.64, which is this, right. Now, you need to look at the critical value, chi-square critical value from table at appropriate degrees of freedom. So, how many rows and how many columns? So, there are 2 rows. So, row minus 1, right, that is 2 minus 1 multiplied by column minus 1, columns are 4, right, it means, so 4 minus 3, sorry 4 minus 1. So, this is 1 and 3. So, this 3 degrees of freedom, right. So, just see the critical value at 0.10 significance level at 3 degrees of freedom is 6.25, which is here, right. So, this is your critical limit. Calculated value is in non rejection area, right. So, we will not reject null hypothesis, right. So, we will not reject null hypothesis, it means job evaluation method are independent of geography. So, there is no relationship between job evaluation method and geography. In other words, we will say they are independent, right, they are not dependent on each other. So, let us look at this question and we will solve this question using Minitab. So, east, west, north and south, old method, new method, so you just enter data In fact, you need not write total values, row of total and row of column. Just multiply, just enter data and go to state chi-square test of for association. Just select all these 4 values, click OK, right. So, let us look at chi-square, yeah, it is 2.76 is Pearson chi-square. So, 2.76 is what we are getting. So, this is the calculated chi-square value and the critical limit is 6.25, right. So, let us look at p value, whether we are rejecting or not, right. So, p value is 0.430. Is this value less than alpha? Let us look at this. So, what is alpha over here? Alpha is 0.10, right. 0.10 is alpha, right, and p value is 0.43. Is p value less than alpha? No. So, we will not reject the null hypothesis. That is what we are saying here as well, right, is not it. So, you need to, you can in fact corroborate your output of Minitab with the manual calculation which you have done, right. Let us look at one more question on this and then we will wind up today's session. So, you would have observed that those people who have got insurance policy, whenever they go to any hospital for treatment, in fact the hospital keeps them for longer period of duration in the hospital. They generally do not discharge patient early. So, a set of data was collected and the objective was to know whether is there any relationship between length of stay and type of insurance, whether people have got insurance are tend to stay more in hospital. So, that is the question, or that was the null hypothesis. So, let us look at this question. So, the fraction of cost covered by insurance company, if it is let us say less than 25% of the total cost of the let us say total bill of the hospital, when the cost of covered is between 25 to 50%, sorry 50%, and when it is more than 50%. So, and the stay in hospital is less than 5 days, between 5 to 10 days and more than 10 days, right. So, let us look at what is this. So, the length of stay is when the fraction covered is less than 25%, there were 40 patients and these days, number of days in hospital is less than 5. So, there were 40 such patients. When the insurance cost covered was more than 50% by the insurance company, the length of stay in hospital for more than 10 days, there were 190 such patients. So, total number of patients on which this survey was conducted was 660. So, null hypothesis is length of stay and type of insurance are independent. As we are saying, it is a chi-square test of independence, right. So, every time we have to use independence over here in null hypothesis statement. So, expected frequency row total into column total divided by n. So, let us look at this. So, this is how you are supposed to use formula for calculating expected for calculating chi-square statistics. So, in this question chi-square statistics is 24.315 and the critical value from table when alpha is equal to 0.01 is 13.27. So, should we reject or should we not reject this hypothesis? Tell me. This is your critical value, right, which is 13.277 and your observed value is this. So, we will reject the null hypothesis, is not it? We will reject the null hypothesis. It means what? Length of stay and type of insurance are related with each other, they are dependent on each other, right. So, let us solve this question using Minitab. We will solve this question and then we will wind up today's session. So, just first delete the output of previous question. So, let us look at length of stay less than 25, the cost covered by insurance company less than 25%, 25 to 50 and more than 50. Here on the stay is less than 5 days, 5 to 10 days and more than 10 days, right. So, you have got 40, 75, 65, then 30, 45, 75, 40, 100 and 190, right. So, just go to state tables, chi-square test for association, you just select all these columns and go to statistics and of course, OK. So, this what is P calculated 24.316, 24.316, yes, just see 24.315 is this. And are we rejecting null hypothesis? Yes, we are rejecting null hypothesis. Let us look at p value and confirm whether we are really rejecting null hypothesis or not. So, let us look at p value, this p value is 0, right. So, alpha is 0.01, p is 0. So, p is less than alpha. So, we will reject null hypothesis, right. So, this is how you can solve questions using Minitab on chi-square test of independence. So, with this let me complete today's session. Thank you very much.